Question 5. Compound S is the secondary alcohol with molecular formula C4H10O. Okay, draw the display formula for the compound S. So this is quite easy. We know that OH cannot bond to the first carbon. It must bond to the second carbon. 1, 2. Because when it's bond to second carbon, so this carbon now with 2 alkyl groups. So it's a secondary alcohol. If the OH on the first carbon, then it just will be primary. Okay, that's why this is the only structure for the compound S. Then part B. S is converted to V in 3-step reaction sequence. First, it will form T after step 1. Step 2, then it will form U. And last step, step 3, will form V. Each step, okay, it will form, of course, it will have different type of reaction. Okay, the first one is quite clear. We know that alcohol now is formed halogenoalkane. It must be a substitution. It's better I use this to explain. Okay, this is the secondary alcohol just now, butane 2O, and the OH after the PBr3 added. Right. So PBr3. So the OH will be substituted by bromine, so it will form 2-bromobutane. After that, it will undergo step 2, and the bromine will substituted by the cyanide and form nitrile. Okay, then the last step, we know that this nitrile will undergo hydrolysis. Here, the CN triple bonds break. This carbon will form COOH. This nitrogen will form ammonia. And this COOH we normally put at the terminals like this. So means, okay, it will be CH3, CH2, CH, CH3, COOH. Okay, so it will form this carboxylic acid, and of course ammonia that form will further react with the acid because we use acid hydrolysis. Ammonia with H plus form ammonium, so it will form carboxylic acid and the ammonium. Okay, let's get back to this question. Okay, part 1. Give the systematic name of T. So it's 2-bromobutane, very easy. Name the type of reaction in step 1. So of course, it's a substitution because the bromine substitute OH. Okay, part 3. State the reagents and conditions for step 2. So bromine to the substituted by the cyanide and form this nitrile. So we know that we must use KCN in ethanol. It must heat under reflux because cyanide is a weak nucleophile. So it need to take times, and of course it need heats under reflux. Step 3 involve heating of this nitrile with dilute acid to form V. So I told you just now, it's form carboxylic acid. So you just need to put C4H9COOH, means this one break. So this one will form the carboxylic acid, and this one form ammonia, react with acid, form ammonium. Right, so just balance it, 1, 1, 2, you get the answer. Okay, part 5. An unlabeled sample contains either STU. So now the IR spectrum below is telling you what is a functional group. From here, we can get this functional group. So it's around 2200 to 2250 wave number. So this one, it shows that the nitrile groups, okay, in the compound. So we know that it must be U, right? Okay, so this is what we can get from the IR spectrum, because from these absorptions we know that, and of course this range, we know that it has nitrile groups there, so it must be the U, right? Explain how this spectrum confirm that the unknown contains U. Very easy, okay, because there is an absorption around this 2200 to 2250, which indicates the nitrile or the CN triple bond N, so present in the sample. Okay, so this is the answers for this question. Okay, that's all. Thank you.